Hello guys, today we're gonna look at this problem of top k frequent elements. I can see I actually have a solution here, but we're gonna look at it and then erase it and solve in a different way because this is not the way it's supposed to be. I mean, it is accepted. It is accepted, but it is a big O of n log n solution because we have this sorting. So we don't want this. So actually, let's actually look at the problem first. Given a non-empty array of integers, return the k most frequent elements. So we have three elements, 1 and 2 and 3. 1 has three elements, 2 has 2, 3 has 1, and we want two most frequent elements. So this is outputting 1 and 2. And note, you may assume k is always valid. 1k number of unique elements. So it's guaranteed to be smaller or equal to number of elements, and the time complexity must be greater than O of n log n, which means that we cannot use this. It's guaranteed that the answer is unique. In other words, the set of the top k frequent elements is unique. You can return the answer in any order. This is very special, unique functionality that you can answer in any order, because if you do sorting, it would sort by some criteria, so it won't appear in any order. So we should find out a way to actually use this. And we don't even have to output if how many those elements appear. We just have to return a set which is inside a list. So the way to solve this is to use bucket sort, and I learned bucket sort when I was in college, but I was kind of rusty and I didn't remember how to do it. So bucket sort is something you can use when you're putting inside an array. So for example, really basic level of bucket sort is that if you have numbers like integers until 1 and 100, and you know that even though the integers are not sequential, there's a gap between integers. If you know it's an integer, or if it's not an integer, you could put into an array as the index, as the integer, or the and then you can make a linked list to actually have like a key as an integer of the index and value as a linked list, so that you can use those and then you can sort those kind of linked list after. And depending on how the linked is how long the linked list is, if it is said to be the linked list has only like 1 or 2 elements, it is supposed to be O of n. And in this case, it is O of n because we don't even have to sort those linked lists. If it exists, we can just put the entire linked list inside this list. So it's guaranteed to be O of n. So enough said, let's implement it. How do we implement this? So first of all, we should actually have a counter, because counter collections would only have O of n. So we can use a counter, and we'll just say CTR for counter. And yeah, this does a lot of things. In Java, we would have to do like 5 lines, at least like 4 or 5 lines to do only this. And as we make a counter, we want to also make a dictionary that has the value as the key. So we're gonna iterate this as key value pairs. Key value in ctr.items, and we're gonna make a hash map. HS map, and then we're gonna put value in here, and key. So now this would have, like, what I just did is that I put like 3 as a value, and value as in 1, and 2 as a value, and value is 2. 1 as a value, and the value is 3. But the problem of this is that we should also take care of duplicates. What if there are like one more 3 element item? So what if the nums is not this, but nums is and we have another 4, 4, 4. What would happen with this? And now we would have, we also want to have 4 as a value of 3. So what we do is that if h.value exists, then we would just append. I believe this also works. And if it doesn't exist, we would just make it with an array list with the key. So now it will make an array list that has 1 and 4 in it, and this would have 2 in it. This would have 3 in it. So with that said, I would just do 4. And now we're all done with the hash map, and now we just want to iterate how many times? We just k times, for I in range of k, because we just want to return k elements. And actually, this would not be such a great idea. We also want to iterate from the most biggest index, which would obviously gonna be n, the number of elements. So length of keys. length of keys, how can we get that? I would say max would be length of ctr.keys. I don't know if this will work, but we can try. Range of till -1 -1. Would this work? Maybe. We'll see. I've never done this before, like in Java or other languages, C# or other languages. There's like 4 like we use this syntax for int I equals 0, I, something like this, but this is in Python we use range, so I hope it does the same thing as this. But we'll see. And after this, we'll do mx. We'll just see if the hash map has that value, and we'll just append to the output. Output dot append what? Oh. And we'll first see if the hash map has that value, which is bucket, and we'll just make a count. If count is bigger than k, return output. No, it should be exactly k. And until this, we're just going to append for k key and for what's the element in bucket output dot append element. But when we do this, we're gonna, after appending one, we're gonna do count plus equals 1, and when we reach this, so this should be not here, but it should be here, and if this doesn't work, I'm just gonna return none. And then let's see if this works. Oh, okay. Value in sh. I think this is the right context. Okay, so it's accepted. Let's actually submit this. 1 HSI cure. So is this not working? Range Python range downwards. decreasing. 6, 0, -1. It works. It actually doesn't have to do 0, so this shouldn't. This can be. So bucket. Oh, okay. I see what's going on. So if bucket. Oh, if I in sh, then do this. If it's not in, else you can just continue with the loop. Wrong answer. Okay, let's see. So we have 1 of 1, and we will see what is in the HS. So it has 1 of 1, and mx is length of control at keys. What is mx? The max value is 1. So if I in sh count, oh, okay, so this is like an edge case. I'll just return output because yeah, it makes sense because it can just finish the loop without getting caught in this return. So I think now it'll, what? Okay, so max is 1. How is this possible? Oh, okay, got it. So I'll just make it this not counter.keys, but I'll just make it the length of nums. I think this will work. We'll just try because this is kind of painful. Yeah, it works, and it works. Yeah, so we had a few trial and error, but overall, I mean, like in some whiteboard coding interviews, they won't even let you do this, like do print stuff. So you would have to just like test it everything by hand, which is a very useful skill. But the funny thing is that this, it's actually a little bit faster than the n-log-n one. So n-log-n, like big O notation, doesn't necessarily mean it's faster. It means that it's just going to increase the runtime with n getting bigger and bigger. So it doesn't necessarily mean it's gonna be faster. So that's it for today's question, and thank you everyone.